Emotion recognition in adaptive virtual reality settings, challenges and opportunities. This is our outline, starting from introduction, to backgrounds, to challenges, to opportunities. Related concepts and contribution. Emotion recognition is a task of detecting human emotion from various observations, for example, physiological signals and speech. Virtual reality is a computer-generated immersive technology that simulates a realistic three-dimensional environment, allowing users to interact and experience the virtual world. The integration of emotion recognition into virtual reality holds great promise for further advancing human-computer interaction. The virtual environment can be adapted to the user's emotional state. It can be applied in many fields such as education, gaming, and more. For example, in gaming, virtual concept can be modified in a real time based on user emotions. We present challenges and opportunities of implementing ER in adaptive VR setting. Transferring ER systems into adaptive VR setting is not straightforward. We identified the main aspects for which traditional ER differs from ER in adaptive VR. These aspects fall into two broad categories: data modality related aspects and data collection related aspects. We describe these aspects. For each category, we identify a set of challenges and opportunities. In the background section, we pay two modality limitations. Basically, we have 5 main modalities. For biomeasurement modality, there is a limitation. For example, most of these signals could not be used in real-life situation due to cost and complexity. For body motion, ER by body motion is not precise, so it has to be combined with other modalities such as facial and vocal expressions. For speech or vocal, not all VR scenarios need the users to speak. For facial expressions, part of the face is covered by the VR headset in the VR setting. Data fusion between the VR internal camera and the outside camera, which covers the mouth, is another limitation. For pupil dilation and eye gaze, there are few, like lighting condition, person's current mental state, age and health status, and hard to distinguish emotion like anger and surprise as they are very similar. Challenging aspects of emotion recognition in an adaptive VR setting. For data collection, there are few challenges. The first one is emotion elicitation. Emotion elicitation is the process of evoking emotional response in individuals throughout various stimuli. Challenges are there is a lack of comprehensive understanding regarding the key factors that trigger emotions. Also, we have subjectivity, which is a different reaction of each subject to the same stimuli. The current psychological state may influence the emotion regardless of the stimuli. Here we can see the scatter plot of WESAD dataset for 3 emotions in 3 colors, but as we can see, based on an amusement, are integrated. The reason behind this fact is weak elicitation. Another data collection challenge is data annotation. Data annotation is the process of associating an observation like physiological signal, for example, anger. Challenges are self-annotation is challenging as user may not be aware of their emotions. Observation group estimation, which is another method, is challenging as emotion may not be evident, or there may not be agreement among observers. Another data collection challenge is emotional model. Commonly used emotional model in ER are categorical models, which represent emotion as classes such as fear and joy, which are known as Ekmanian models, which consist of 6 primary emotions of fear, joy, neutral, anger, sadness, and surprise. Also, we have dimensional model, which represent emotion as a vector in valence and arousal space, as we can see in the figure. Challenges are traditional models are not tailored for adaptive VR setting. Also, more sophisticated models are required to effectively track user engagement. Another data collection challenge is user and task heterogeneity. Heterogeneity of behaviors and tasks. The same emotion can be expressed differently by different individuals or by the same individual engaged in different tasks. Heterogeneity may depend on various factors such as cultural background, age, gender, and more. It is challenging to develop a general ER system that is effective for different users and tasks. For challenges related to multimodality, we can mention unsupervised representation learning. Unsupervised representation learning, or URL, algorithms try to extract meaningful features and patterns from data without getting the help of labels. One of these techniques are self-supervised learning, where models are trained to predict certain aspects of data without relying on externally provided labels by following relationship and sequences within the data to create supervised-like tasks. SS already showed promising performance on unimodal data in ER in various research, but not multimodal. Challenges are publicly available unimodal VR-based ER datasets are limited, such as physiological and pupil dilation data. Pre-trained models do not guarantee optimal performance when transferring representation to emotion recognition. As we can see in the table, we have two emotion recognition datasets with two different results. For example, Wave2Vec is a pre-trained speech recognition model, and EG Maps is a handcrafted ER feature pack. But the F1 score shows that pre-trained ER models do not always return better results. Another challenge related to multimodality is flexible multimodal fusion. Not always a single modality could satisfy an ER task. Feature fusion on different modality makes more robust models in ER. Choosing modalities should be designed based on a scenario. Challenges are, not always scenarios are unimodal. There are scenarios in which oral communication is needed, but not in all stages like gaming and educational scenarios. Feature fusion of different modalities does not always align with each other and does not always guarantee intermodal correlations. This chapter is related to opportunities for emotion recognition in virtual reality. In data collection, there are several opportunities, for example, collecting datasets for emotion recognition in adaptive VR settings. VR provides a more suitable environment to collect emotional datasets, which it comes from tracking users' signal across different modalities, evoking stronger and more genuine emotional reactions, and VR allows for precise control over environmental factors. As an example, theory of flow, or TOF, is a proper technique for data collection. Theory of flow makes the connection between the task difficulty, individual skills, and emotional response. We argue that using TOF sync with emotion elicitation is well suited in adaptive VR setting for ER. By TOF, we receive an anxiety, engagement, and boredom emotions rather than traditional Ekmanian emotions. As an example, authors in reference number 4 present a VR platform called Magic X-Room. As Magic X-Room can collect extensive multimodal datasets for ER in adaptive VR scenarios. It happens by precise control over emotion elicitation materials. The task difficulty dynamically adjusted based on participants' skills level and feedback to achieve engagement or the flow. It happens by increasing difficulty if the user is bored and decreasing the difficulty if the user is frustrated or anxious. Another opportunity for data collection is personalized data collection. As mentioned before, creating a unique ER system for all individuals is very challenging. Instead of creating universal ER system, creating personalized dataset and constructing custom model is preferable. VR provides situation for personalized data collection by gathering data of individuals in different seasons of a specific task with different spans, collecting extensive data on individuals in various tasks and situations, using a VR environment to get instant multimodal feedback in each context for all individuals to build personalized ER models. Another opportunity for data collection is behavior-driven emotion recognition. Not always emotions are measured by traditional vocal facial expressions, body emotions, or physiological signals. Behavior-driven emotion recognition is an approach to identify emotions by analyzing subjects' observable behaviors. Analyzing the user interaction with the surrounding environment like objects is a decent clue for ER. VR is capable of providing such an immersive environment for user-environmental interactions. To our knowledge, no one has tackled this field yet. By integrating behavioral data and traditional signals, an accurate and comprehensive model is achievable. Another opportunity for emotion recognition in virtual reality is called shared multimodal representation learning. Multimodal representation learning is the automatic extraction of meaningful and informative features or representation from raw data of multiple modalities. Shared multimodal representation learning, or SMRL, is trained to learn a shared representation space that is common to multiple modalities. It is conducted in other fields successfully, and to best of our knowledge, SMRL in ER under a VR setting has not been conducted yet. Creating a space to align different modalities in ER under the context of VR could be a solution for flexible multimodal fusion mentioned in the challenge. As conclusion, adaptive virtual reality increases user engagement by creating an immersive and personalized environment. We critically reviewed the current landscape of ER and its suitability for adopting VR setting. We introduced the ER modality for their limitation in integrating them into the VR setting. We listed challenges for adapting ER to adaptive VR and categorized them into data collection and multimodality. We listed opportunity for adapting ER to adaptive VR and categorized them into data collection and shared multimodal representation learning. Here we can see some important references. Thank you so much for your attention.